All right, this is the big one. Let's talk about how to determine the pH at different points of a weak acid, strong base titration. This is what the titration curve is going to look like, and we're going to look at those 5 positions on that curve and talk about how the calculation changes. So let's start at point 1, where we only have the weak acid in solution. Because it's a weak acid, you can't just look at its concentration, you have to use the Ka value. So to be given the Ka, you're going to set that equal to the concentration of H plus times conjugate base divided by the concentration of the weak acid. So it's essentially X squared over that weak acid concentration. Solve for X, that gives you the H plus. You plug that back in, you have your pH. Now we're going to move into the buffer region, and this is just any point on the curve before the equivalence point. And in this region, you're going to use the Henderson-Hasselbalch equation, which is just pH equals the pKa plus the log of the conjugate base over the weak acid. You can use the concentration or you can just use the moles. So we're just going to have to use a BCA table before change after to find the moles of each of those. pKa is equal to the negative log of that Ka value. And point number 3 is a special point in the middle of the buffer zone. This is the half equivalence point, where we have neutralized half of the moles of acid and base. When that happens, your moles of conjugate acid, conjugate base are equal, so that log becomes 0. So therefore, at the half equivalence point, remember the pH is equal to the pKa. Should be your easiest calculation. Which moves us into the most tricky calculation, the equivalence point. When you're doing a strong acid, strong base titration, this is the easiest point because it's always equal to 7. However, with a weak acid or a weak base, strong acid, strong base titration, it is so much harder, but you can figure it out. So what you're going to have to do is your pH is going to be based on the conjugate base in solution. So you're going to have to use some ice tables. You're going to have to figure out what's going on, find the concentration of that conjugate base, then think about its dissociation in water, solve for Kb, use Kb is equal to OH minus times the concentration of the weak acid over the conjugate base, essentially X squared over the concentration of the conjugate base, solve for the hydroxide, and then solve for the POH, subtract from 14, and you finally have your pH. Thankfully, the next calculation is a lot easier. When we're looking past the equivalence point, you're just going to focus on the excess hydroxide in solution. That comes from the strong base. Solve for the POH from that, and then just subtract from 14. You have your pH. Titrations are tough, but so are you. Check out my website for a free 1-page guide to these types of calculations. Follow Chem with Corinne for more content like this.